Hello, let's do this Openstax Calculus Volume 1 problem from section 2.4, which is the section on continuity. And here we have f of x given by this piecewise definition, and we're going to start by sketching the graph of f. So let's just focus on that, and I'm not going to read the other part yet. So we'll sketch the graph of f. And, well, that might be in itself a bit of a challenge. Let's check it out and maybe see if we can do the easier things first. I think when x is greater than 1, we have y equals 3x. Let's just play around or work on that one first. Okay, so let me make it clear that with this whole thing function has two different rules. It has y equals 3x. It has y equals 3x when x is greater than 1. And it has y equals x cubed when x is less than 1. And what I'm going to do is put a little dotted line where, well, maybe I shouldn't, but I was going to put a dotted line where x equals 1. I guess I better not do that. But let's start off with y equals 3x. That's a line through the origin with slope 3. And what I'm going to do is I put a dotted line there first. So I'm just representing it by a dotted line. And the reason for that is I want to remind us what the graph of y equals 3x looks like. The slope is 3. So this is a line, slope equals 3, and the intercept is 0. But we're only looking for x greater than 0. So what I'm going to do is then come back and color over starting when x equals 1. And I'm going to put a circle there. So that's starting at 1. I'll even put the point, which is 1, 3. And so the other part I don't want. Actually, I'm going to go back and erase that other part. So that's what I have there. And then for y equals x cubed, I can do the same sort of routine where I'll sketch the graph in lightly with a dotted line. I feel like maybe we should plot some points, but it goes something like way up here. So how far should I zoom out? I think I'm not going to include all this. Okay, so that's y equals x cubed, and you know, you can plot some points. Do we always have to plot points on a little chart, or can we just sort of do it in our head a little bit? But see, 1 cubed is 1, and that's over here. Negative 1 cubed is negative 1, and that's over here. But I'm going to actually color that one in. And then negative 2 to the third power is negative 8. But see, I'm only using the part when x is less than 1. I'll erase the other part. And it looks like a parabola opening down when x is less than 0 and a parabola opening up. I'm saying it looks like, I'm not saying it is, but that's how it looks. And I'm going to erase the rest of that part there. So I think that does it, right? So this point down here is 1, 1. So I'm missing something. I think I got it. I mean, is it possible to find a value of k such that f of 1 equals k, which makes x continuous for all real numbers? B, no. Okay, so what's going on? For part B, well, what's going on is I got overly ambitious on my graph and ran out of space. So that's part of what's going on. Okay, For B, look, the limit of f of x as x approaches 1 from the left is 1. I mean, I can, now that I sketched the graph, I can really see that. And the limit f of x, x approaches 1 from the right, is equal to 3. So limit f of x, x equals 1 from the left, x approaches 1 from the left is not equal the limit of f of x, x approaches 1 from the right. F has a jump discontinuity at x equals 1. We cannot make f continuous at x equals 1 by defining my handwriting is starting to get a little messy, by defining f at x equals 1 to equal any value, to equal a value of a k. I mean, it's not going to do it. It'll still be discontinuous because the limit doesn't exist. What would I make k equal to that would make that work? It's never going to be continuous because there's a jump discontinuity. The limit from the left doesn't equal the limit of the right. And if I came along and said, well, let me just make k here or wherever, it's not gonna help. So the answer is no for part B. Make sure I get that, and the rest was explanation. Okay, so got a little practice sketching the graph of a function, piecewise graph, so that was good. And then we talked about the idea of a little bit of jump discontinuity. A jump discontinuity is where the limit from the left exists, the limit from the right exists, but they don't equal each other. So it's not continuous because the limit doesn't exist, but it has a jump discontinuity, as you can see from the picture, from the graph. Okay, that's all.